Morning. Am I audible to you guys?
Yes, ma'am. Good morning,
Morning.
ma'am.
Morning. So, Ankusha wanted to take my class, so I'm shifting my class. Okay. So today we will start the subject. I guess your syllabus is already there. In the last class I provided you guys the syllabus. So the name of the subject is formal language. Language. Okay. Okay, so in last class, I already provided you guys a preview about like what is an automata and all. So basically, this is a theoretical subject, and here we are going to learn the theory and the concept behind any mathematical model or computing model. Okay, so from this subject, you will get questions from in many competitive exams. So it's an important subject, even though it's a bit difficult. And not exactly difficult, it's a scoring paper too. Just that. Uh, Sometimes it is a bit confusing because of its ambiguity. Whatever. So here you have to know the three main things. Okay? Three main things. Okay. Normally for us human, we have our own language. We can speak in English, we have Hindi, Assamese, and so many other languages are there. And those languages are for communication. Right? So similarly, computers also have some language. Okay, normally we know that it's just binary. For computers, it's just 0 and 1. Okay, and apart from that, it also follows certain grammar and language. Okay, so for this particular subject, you have to know three things. One is language, one is automata, and third is grammar. So whole subject will just revolve around these three things. Okay. So in normal language, like for English language, for example, we have certain building blocks, right? Language means it's like a whole language set of sentences, right? Before that, what's the origin? We have symbols, right? Remember in early days also, before like proper language, people used to communicate with the help of symbols. So here also there will be certain symbols. And symbols can be anything. Okay? Symbols can be just anything. It can be zero, it can be one, anything. It can be any letter, it can be alphabets, it can be pictures, or anything. It's simply just any entity. It can be anything. It can be letter, alphabet, anything. For example, you can just say zero, one, A, B, and it can be A. These are just symbols. Okay. With the help of these symbols, you are going to construct an alphabet. Okay. alphabet means next comes your alphabet. So what is an alphabet? Your alphabets are basically finite set of symbols. Alphabets means it's just a finite set of symbols, and normally we define it by this sigma. Okay, this is a sigma symbol. So we define alphabets with the help of the symbol sigma. Okay. So thing is, first there will be certain symbols, and with the help of symbols, we can generate alphabets. Some example can be like, suppose A and D. So this is an alphabet with two symbols A and B. Then you can also write like 0 and 1. Okay, this is another type of alphabet. Just keep it different. Okay, then you can also keep capital letters A, B, C, and so on. Okay, so this is an alphabet with two symbols A and B. This is another alphabet with symbols 0 and 1. This is another alphabet with symbols A, B, and C. Okay. Next, what is the another thing? First we have symbols, then we have alphabets, then now we can create certain strings or sentences. Okay, so what will be a string? So strings will be finite set of symbols from alphabet. Okay. So string means, so symbols just can be letter, numbers, anything. Alphabet means finite set of symbols. Then we can create strings or sentences, which is nothing but a finite set of symbols from the alphabets. Okay. So this is your string. Next, we have language. Okay. The strings can be anything. Okay. Suppose for if you say string, you can also denote a. In some cases, it is denoted by W. In some cases, you can see string is also denoted by sigma sigma. Okay. In some cases, okay. But mainly sigma is used for the development. So string can be like what? It can be anything. For example, you have two symbols, okay? A and B. Okay, this is your alphabet and you have two symbols A and B. Now, what are the types of strings you can create with these two elements? What are the possible strings? You can create like, suppose A, B, B, A, then you can also create A, 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 B, A, B, it's simply if you have two symbols, then you can create like 2 power 3 combinations or based on the situations. Like if I do not provide any conditions, then you can create as many strings as you want from this 12. It can be in any sequences. Right? It can be in any sequences. Okay. Now, if I say you need to generate a string which will be of length 2. Okay. Now I'm saying the length of the string length of the string should be 2. Okay. 1, 2, 3, 4, 3. Yeah, you can use any symbols. In alphabet, if you want to keep a 1, 2, 3, 4, it's fine. Okay. But the um, like general or conventional way is that either you just keep AB or you just keep 0, 1, 2, 3. Okay, it's up to you, not a problem. Okay, so if I don't put any condition here, you can form any strings from these two labels. It can be of any length. Okay, and it can be in any sequence. Now, if I say the length of the string should be 2, then you can create maybe just AB, BA, and you create anything else. You can also create AB and create BB like this. So these are the only possible strings you can create. If I say the length should be 2, that means what? This is your finite. This is a finite one, finite string. Okay. And this one, as I said, there is no length. It can be infinite. Okay. So as we know what is a string, now we can generate a language. So what will be the language? Language means it's just collection of strings. Okay, language is nothing but collection of strings. So when this is nothing but your language. Okay, so your language can be both finite and infinite. So what are the things we learned till now? So first, we are just revolving around language. Okay. So for a language to create, like for any language, even the human language, we use certain symbols. Okay. With the help of symbols, we can generate alphabets. Okay. Symbols can be anything. It can be A, B, 0, 1, or it can be any symbol, alpha, beta, sigma, whatever symbol you want to. Then with this help of single symbols or with a finite set of symbols, we can create alphabet. Okay. So alphabet normally denoted with this sigma sign. Okay. So here this is an alphabet. So there are two symbols A and B. Like here you can keep 0, 1, you can keep anything in here with three symbols A, B, and C. Okay. Then with the help of alphabets, we can create strings. Okay, so string is just a finite set of symbols from the alphabet. Now, since we have a string, or you can think of a sentence, now we can create a language. Okay? We can create a language. So, language is nothing but the collection of strings. Or sometimes we can also say appropriate string. Why I use appropriate is because sometimes we can provide some conditions. Like here I say the length of the string should be 2. Okay. Then in this particular strings or language, you cannot put any alphabets with the length 3. Okay. Now here I didn't provide any conditions. So it can be of any length. You can put anything. Okay, so now you see the language can be finite and infinite. Okay, and we can find the length of any string. So here length of the string is 2. You can also, here it's of just any length. If I say, suppose I just use this symbol W here, this is maybe 0, 1, 0, 0. So length of the string is what? 1, 4, 3, 4. So here length of the string is 4. And again, if I say symbols like A, B, then length of the string is just 2. So language is formed over your alpha or the alphabets, and it can be finite or infinite. Now finite, I just provided the string. Now if I say you need to find a language, okay, here language you can denote as a symbol of L. Okay, L means your length. So I can say L1 is maybe the set of string with length 2. Here I said, right? So you can just represent L1 is equal to AA, B, BB, and BA. So this is your finite language. Okay, you can just count. Now, if I say there's another language, which I just said, set of all strings starting with A, you can give another condition and ending with A. Okay, so this language you can say starting with A and ending with A, but I didn't provide any length. So it can be like anything, A, 3A, then you can give 4 A's, then A, B, A, B, B, A, and so on. Okay. There are so many possibilities that you can start a string with A and end with A. So this one is finite. This one is infinite. Okay. So language part is clear. Language one, language two. Okay. So these are just basic terminologies. Okay. You just have to know what is a symbol, what is alphabets, what's a string, and language. Now, here I say there are two more things. It's also kind of basics. That is clean start. Okay, name is clean start. Okay, sometimes this question is asked many times in different places or competitively. So, what is a clean star? Okay, clean star you can also represent as this sigma star. Okay, so you already know a sigma can be alphabets. That means set of symbols. Okay, so now it comes as a power of something. Now, if I say power sigma power 0. That means what? There is nothing there, right? No symbols are there. Okay. So still it's a string. It's an empty string. Okay. Empty string can also be represented as lambda or epsilon. Both are correct. You can use anything. Okay. Empty string or null character, sometimes also called null. You can represent it with the help of epsilon or the lambda sign. Both are okay. So you can use any of them. So an empty string means this one. Now, what is a clean star? Clean star is simply the set of all possible lengths, possible string of length to some length. Okay. Clean star means set of all possible strings of length. For example, n, you can keep n, you can be, it's just length, certain length. I'm not defining the length, can be of any length. So, what could be the possibilities if you have the symbols A and B? Okay, so clean star will be, it's including the null character. Okay, it can be A, can be B, AA, AB, BB, AAB. It can be anything. Simply infinite. Okay. So if your alphabets is this one, you have two symbols, then clean star is simply the set of all possible strings of length n. Okay. And it also includes the empty character or the null string. Okay. It's the null string. Okay. Now we have another term is clean closure. Or sometimes we say plus this positive plus. So this one we represent as plus to the power plus. So this is also same. It's also infinite set of all possible strings except the empty string. Null string to Q. Null string is also included here. Means we recognize it as a string. Okay. In clean star is a set of all possible strings of length n, including null, including empty string or null. Okay. But in clean plus, it is excluding the null. That means if the symbol is A and B, then your clean plus will be simply all strings except the null. Just remember the difference. Everything is just infinite set, okay? This is also infinite set, just that null character is not included in clean closure. But in clean star, we include the lambda. Okay, so you can also represent it clean plus equal to clean star minus 0, right? Or this same thing you can also represent as lambda. So both are just same. Just remember in the clean star, we include the null string, and in positive one, clean positive or clean closure plus, we do not include the null character. Here, there is the null character and there is no null character here. Just remember the difference. Okay. Now, what's the purpose of your automata? Okay, what is automata? Automata, automata is a plural form of automaton. Okay, main term is the automaton. Single. Two elements. How can we get AAB? It is a possibility, means you just have two symbols, right? But you can create so many other strings. For example, if I give you the alphabets like A, B, R, S, suppose A, B, R, S, you have symbols A, B, R, S, normal image. You can just make so many other words with this, right? It's like permutation and combinations. From two symbols, you can create infinite set of characters. There can be 1A, there can be 2A, there can be 3A and 4A and all. Okay, these are just the symbols. You have only two sets of symbols and you can create strings with any length. Okay, unless I say the length of the string should be 2 or length of the string should be 4 or length of the string should be 5 and so on. So if you want to go deeper, you can say 0 will be string with length 0, right? Then if I say 1, then string with length 1. This one is lambda I know. Then suppose you have symbols for 1 and beyond. Then possibilities only A and B. Okay. Now if I say 2, then string with length 2 means what? It can possibly only infinite. Yes, there can be so many other things. So here length will be AA, BB. You can keep AB, you can keep DA. Okay. Then I say the power is 3. That means string with length or the power you can say 3. So it can be A, B, 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 A, B, B, A, B. Can write B, A, can write B, B, A, and so on. Okay, there will be 8 combinations 1, 2, 3, 4, 5, 6. You can say A, B, A. You can say B, A, B. Okay. So now, similarly, there can be other possibilities. You can just create any combinations with length or power 4. So similarly, if you keep down, that means what? This will be a clean star, right? So it is nothing but set of all these symbols. It includes lambda, it can be A, it can be B, AA, DB, can be AAB, BAA, you can keep AA, B, B, and so on. It's an infinite. That's the clean style. It's simply set of all possible strings you can create from the symbols. That's how we got the clean style. Also includes the lambda. In positive one, we don't include the empty string, or we do not consider the powers 0. Okay, you just have two symbols and you can create any strings with any length. Okay, and set of all these strings is the language. Okay, these are nothing but the string. This is the string, this is the string, this is string, 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 and whole thing, whole set is the language. Okay, so now comes the automata part. What it does, your automata part decides whether the language is finite or infinite. So mostly in exams, they just give a part of the string. Okay, they just give a part of the string, then ask question whether the string is part of that particular language or not. Okay, whether the string is acceptable by the mathematical model or not. Okay, so main purpose of your automata, which is nothing but your mathematical model, is to find out whether language is finite or infinite. Okay, so like in formal way, you can say automata is a machine Automata is a machine that can perform itself by following a predetermined set of predetermined set of rules or operations. Another term you can say automaton is an abstract mathematical model which helps us to find out whether the language is finite or infinite, or it's an self-acting machine. Okay, and most importantly, automaton can be anything. There are four types of automaton. Okay, one is finite state machine. Finite machines. Finite machine means it has finite number of states. Okay, finite automata or finite state machine. Then we have push down automata. Then we have LBA. LBA means linear bounded automata. Then we have Turing machine. I guess you guys already heard of Turing machine. It's from the mathematician Alan Turing. So before inventing the Turing machine, they also followed the stages of finite machine. Okay, so each of these automata has different language. Okay, so here I only mention Language is nothing but a collection of certain strings, and language can be both finite and infinite. It can be possible only in infinite. It can be finite also. Like if you increase the length, or the power, it will go like infinite stages. But if you just keep it just two, it will be finite. Then again, previously I gave example. Um, it can be a language which start with A and ends with A. So this one will also be infinite. Okay. So language can be only finite or infinite. Again, from this language, there are four types of language. Okay. Four types of language: regular language, context-free language, context-sensitive language, and recursively enumerable language. We will again, for each of this language, we have different grammar. Okay. So now you know we have set up symbols. From symbols, we can create alphabets. From alphabet, we can create strings. From strings, we can create language. Okay. Now again, since a language, even for us also, English also, or any language, we follow certain grammar, right? We always follow some grammar for the proper construction of your language. But similarly, here also there will be grammar. With the help of the grammar only, you can create, means you can just follow the instructions of a language. Okay, and these grammars, there are four types of grammars again, like type 0, 1, 2, 3, 4, and it has different names. And based on these names only, the languages got their names too. And each of these four automata I mentioned here accept different language. Okay, each of these finite automata accepts different language. Finite state machine accepts regular language. Regular. Push down automata accepts context free. Okay. Linear bounded accepts context sensitive. We'll come to this part in next class, okay? And last, Turing machine accepts unrestricted, or you can say recursively, enumerable language. Okay. So automata is an abstract mathematical model which can perform itself by following predetermined set of rules, and most importantly, it tells us whether a language is finite or infinite. So automata is in plural form, singular is automaton, can be of four types: finite machine, push-down automata, linear bounded automata, Turing machine, and each of these automata accepts four different kinds of language. Okay, so let's just stop sharing here. So channel videos. As I say, this subject is a bit confusing, so you have to be like very attentive in the class. Switch on your videos. Video on करो सब.
মেম মোৰ লেপটপৰ ৱেবকেম নাই মেম।
লেপটপত এক্সট্ৰাকে ৱেবকেম লগোৱা নেকি?
মেম এইটো মানে লেপটপত এডিচনেল টাইপ দিছে মেম আৰু জি ষ্ট্ৰিক্স মানে you can opt for the webcam but it is not included.
बाकी वीडियो ऑन करो नहीं तो नहीं मिलेगा अटेंडेंस। हाँ क्लास कर रहे हो या ओके ओके इसका नहीं हुआ लेट इट गो just continue tomorrow. So just ending it. You all